Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 35, in which I will give the details concept of Poisson distribution in probability theory. Now, we wish to see that why we think about Poisson distribution. As we know, binomial distribution, which helps to find the probability of random variable for r number of successes among n trials. In binomial distribution, the probability for the random variable x equal to r is NCR p to the power r q to the power n minus r equal to 0, 1, 2, 3, n. Here, small p be the probability of success in a trial. Small q be the probability of failure in a trial. N be the total number of trials. R be the number of success trials. Now, with the help of a problem, we will conclude that why Poisson distribution needed. Here, problem is find the probability of 4 defective items in a sample of 400 taken from a large lot if there are 1% defectives in the lot. Here we solve the problem. Here given that number of trials n equal to 400. P be the probability of success in a trial, that is 1%, that is 1 by 100 equal to 0.01. Q be the probability of failure in a trial, which is equal to 1 minus P, 1 minus 0.01, that is 0.99. R be the number of success trial. Here number of success trial be 4. Here to get the defective items be the success trial. Now we use the formula for binomial distribution. Probability for x equal to r, n c r p to the power r q to the power n minus r. Here n be 400, c r be 4, p be 0.01 to the power r equal to 4, q is 0.99 to the power n equal to 400 minus r equal to 4. This is equal to 400 C4, 0.01 to the power 4, 0.99 to the power 396. Here we see that this is very laborious task to solve this problem, because here we get 0.99 to the power 396. So, to cope with this situation, we use another formula in which we use the concept of approximate binomial distribution. And this distribution is known as Poisson distribution. Therefore, Poisson distribution is the limiting form of the binomial distribution. When number of trials n is very large, that is n tends to infinity, and probability of success in a trial p is very small, that is p tends to 0. But n multiply p, their product, is a finite quantity. And we use these concepts to find a new distribution that is called Poisson distribution. Now we derive the formula for Poisson distribution as a limiting form of binomial distribution. Since in binomial distribution, probability for random variable x equal to r equal to NCR p to the power r q to the power n minus r, where n be the number of trials, p be the probability for success in a trial, q be the probability of failure in a trial, r be the number of success trials. Here r equal to 0, 1, 2, n. Let n tends to infinity and p tends to 0, but np equal to a finite quantity equal to lambda. Let this is number 1, this is number 2, implies that p equal to lambda by n. This is number 3. From 1, p x equal to r equal to NCR means n minus 1, n minus 2, n minus r minus 1 by factorial r. P to the power r means lambda by n to the power r. Q is 1 minus p, 1 minus p to the power n minus r. This equal to implies that p x equal to r equal to n minus 1, n minus 2, n minus r minus 1 by factorial r multiply lambda to the power r by n to the power r. Here 1 minus p means lambda by n to the power n minus r. Here we have r number of n. So we may write here n by n multiply n minus 1 by n multiply n minus 2 by n multiply n minus r minus 1 by n. Here lambda to the power r by factorial r. Here we may write this 1 minus lambda by n to the power n by 1 minus lambda by n to the power r. Implies that p x equal to r equal to here lambda to the power r factorial r, this is factorial r, 1 multiply 1 minus 1 by n multiply 1 minus 2 by n multiply 1 minus r minus 1 by n multiply, we may write this 1 minus lambda by n to the power minus n by lambda to the power minus lambda. Here, if we multiply minus n by lambda and minus lambda, we will get n. Here we have n by 1 minus lambda by n to the power r. This is number 3. Now, let minus n by lambda equal to x tends to infinitive as n tends to infinitive. Therefore, 1 minus lambda by n to the power minus n by lambda equal to 1 plus 1 by x to the power x, and this is equal to e as x tends to infinitive. That is, for n tends to infinitive. This is number 4. Taking n tends to infinitive in theory and using 4. In theory, we get p x equal to r equal to lambda to the power r by factorial r. Here, if n tends to infinity, then 1 by n equal to 0, that is 1. 1. Here also n tends to infinity means 2 by n equal to 0. 1 multiply multiply 1. Value of this is e, that is e to the power minus lambda by, here n tends to infinity, then lambda by n equal to 0 and remains only 1 to the power r, that is 1. Implies that p x equal to r, probability for random variable x equal to r, we get the formula lambda to the power r e to the power minus lambda by factorial r. This is the formula for Poisson distribution. Now we will show for Poisson distribution sigma r equal to 0 to infinity, probability of random variable x equal to r equal to 1. Now we prove this. Prove. In Poisson distribution, we know that probability x equal to r, random variable x equal to r equal to lambda to the power r e to the power minus lambda by factorial r, implies that sigma r equal to 0 to infinity p x equal to r equal to sigma r equal to 0 to infinity lambda to the power r e to the power minus lambda by factorial r, and this will be equal to r equal to 0 means lambda to the power 0 e to the power minus lambda by factorial 0 plus lambda to the power 1 e to the power minus lambda by factorial 1 plus lambda square e to the power minus lambda factorial 2 plus lambda cube e to the power minus lambda by factorial 3 plus dot 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 dot. And this is 1, this is also 1. Here we take common e to the power minus lambda. Here remains 1 plus lambda by factorial 1 plus lambda square by factorial 2 plus lambda cube by factorial 3 plus dot 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 this. This equal to e to the power minus lambda multiply the value under bracket will be e to the power lambda. This is e to the power minus lambda plus lambda e to the power 0 equal to 1. Proved. Since sum of all probabilities for random variables x equal to 0, 1, 2, dot 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 is 1, hence Poisson distribution is a probability distribution. Hence Poisson distribution is a probability distribution. Now we will show the recurrence formula for Poisson distribution. Since in Poisson distribution probability for random variable x equal to r equal to pr equal to lambda to the power r e to the power minus lambda by factorial r. This is number 1. Implies that p r plus 1 equal to lambda to the power r plus 1 e to the power minus lambda by factorial r plus 1. This is number 2. Implies that p r plus 1 by pr equal to lambda to the power r plus 1 e to the power minus lambda by factorial r plus 1 divided by lambda to the power r e to the power minus lambda by factorial r. This equal to lambda to the power r plus 1 e to the power minus lambda by factorial r plus 1 multiply factorial r by lambda to the power r e to the power minus lambda. Here lambda to the power r plus 1, here lambda to the power r. Remains only 1 lambda. E to the power minus lambda, e to the power minus lambda cancel. Here factorial r, here factorial r plus 1. Only remains r plus 1. Implies that p r plus 1 equal to lambda by r plus 1 pr. This is the recurrence formula for Poisson distribution. When r equal to 0, we get Here from this r equal to 0 from 1 lambda to the power 0 p0 equal to lambda to the power 0 e to the power minus lambda by factorial 0 lambda to the power 0 1 factorial 0 1 e to the power minus lambda. Putting r equal to 0 in this is number 3. In theory we get p here 0 plus 1 equal to lambda by 0 plus 1 p0 implies that p1 equal to lambda p0 is e to the power minus lambda. This is number 5. Putting r equal to 1 in theory we get p1 plus 1 equal to lambda by value of r is 1 plus 1 here p1 implies that p2 equal to lambda by 2 p1 is here lambda e to the power minus lambda. This is equal to lambda square by 2 e to the power minus lambda, and in this way we may find other values of the probabilities for random variable 3 4 dot 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 dot. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.